Okay, we're going to start the second part of our trig unit, which is curve sketching uh, and related rates and our one last set of derivative rules. But today we'll focus on curve sketching. We know the process just with trig is getting used to looking at it from a trig perspective. And then tomorrow we'll do extreme value theorem, mean value theorem from a trig using trig functions. So you can turn to page 2, and then also have your calculators out since you'll see a problem like this on the test where you have to get all the information, increase, decrease, all that, but you also have a calculator to confirm all your steps as well. So I'm going to let you use your calculator. So I want you guys to be comfortable with everything that comes with that. Okay, so let's go to y equals and go ahead and type in that function. Interval is from negative pi to pi. So under window, you can adjust x min, x max to from negative pi to pi. I have y min, y max, negative 10 and 10, but we can always go back and adjust that if it's not as clear as we would like. Hit enter. Okay, so we know that after we gather all the information from first derivative test for concavity, we should be able to create a graph that looks like this. Yeah. Okay, let's go back to the problem here. We're just going to gather everything from calculus perspective now. Okay, so given our function x minus 2 cosine x, on the interval from negative pi to pi, find the intervals increasing, decreasing, relative max, order pairs, points of inflection, order pairs as well, intervals of concave up, concave down. So we're just going to go through first derivative test for concavity, create our sign lines for both our f prime and f double prime. Start with y prime. Derivative, x becomes 1, cosine becomes a negative sign. Negative sign will push that negative to 2 negatives will make positive. After we find y prime, critical point, set y prime equal to 0. So subtract 1, it's negative 1 is equal to 2 sine x. which is the same thing as saying 2 sine x equals -1. We want to find what radian measure will allow sine to be equal to -1/2. It's going to be in that 5/6 family. Sine will be negative in the third and fourth quadrant. But the issue is that these are outside the interval, right? Because if we look at our interval here, here's 0, here's pi, here's 2 pi. Our two solutions here are 7 pi/6 and 11 pi/6. And we want to have something that is living in this interval here, from -pi to pi. So 7 pi/6, 11 pi/6 is outside the interval. But we can always create coterminal angles by adding or subtracting 2 pi, see if we have anything that are critical points, variations of these that land in the interval that we want. So, or we can always add or subtract 2 pi. See if we have something in the interval that we want. So if I subtract 2 pi from 7 pi/6, do the same thing with 11 pi/6. Now, -5 pi/6, which is the same thing as 7 pi/6, but then just a coterminal angle on the negative side. These are better suited because they fit inside the interval from -pi to pi. But whenever we see -5 pi/6, we can just treat it like how we would normally treat 7 pi/6, third quadrant, and then -5 pi/6, same thing as 11 pi/6, fourth quadrant. Okay, so now we have our critical points. Here's my sine line. Now, sometimes it's going to be hard sometimes it's hard to test points that doesn't quite land inside the interval. So I'm going to have you use your calculator to kind of help you see what's going on. But just for now, normally we will want to test values in each subinterval. So here between -5 pi/6 and -5 pi/6, that's third quadrant, that's fourth quadrant. We can test -pi/2. Put that into y prime. -pi/2 is the same thing as 3 pi/2. So sine of 3 pi/2 is negative. -1 times 2 is -2. -2 plus 1 is negative. So our graph is going to be decreasing in that interval. Between -pi/6 and 0, and pi, I'm going to test 0. 2 sine of 0 is 0. 0 plus 1 is 1, so positive. And then based off of our graph, even though it's hard to find critical points here, we can see that the graph is rising slightly there. Rising, falling, and rising. Okay, from our sign line, we can tell our relative max is at negative 5 pi over 6. We have a relative min at negative pi over 6. So we're going to try to find the exact value using our function. So plug negative 5 pi over 6 into the original function to get the y value of the relative max. Again, we know that negative 5 pi over 6, we'll treat it like 7 pi over 6. And we think about our unit circle value, 7 pi over 6. Our order pair is negative root 3 over 2, negative 1/2. Cosine of 7 pi over 6 would be negative root 3 over 2. Multiplied by negative 2 there, so minus 2 times negative root 3 over 2. All right, so there's our y value for our relative max. Okay, relative min. Put that x value back into the original function to get the order pair. We'll treat negative pi over 6 the same way that we treat 11 pi over 6. Basically in the same family. We just know that it's in the fourth quadrant, so positive x and a negative y. So positive root 3 over 2 here. Okay. All right, we've gathered everything that we need from y prime. We see our intervals of increase. We see our intervals of decrease. We can fill those in later. We have order pairs of relative min, our relative max. Okay, so now let's go back to, y prime and build our y double prime. Okay, so second derivative. Sine becomes cosine. 1 goes to 0. Set second derivative equal to 0. Okay, we ask where is cosine equal to 0? Cosine is equal to 0 at pi over 2 and 3 pi over 2. But again, our interval is from negative pi to pi. pi over 2 is fine. But 3 pi over 2 is outside the interval, so we can always see if we can find something that inside the interval by subtracting or adding 2 pi. So negative pi over 2 is something that lands inside negative pi to pi, and it's a variation of 3 pi over 2. So we can keep that critical point, just have to adjust it and find a coterminal angle that fits. Okay, so we have two critical points, pi over 2 and negative pi over 2, which is a variation of 3 pi over 2. Okay, second derivative sine line. Okay, between negative pi over 2 and negative pi, we can choose, let's say, negative 2 pi over 3. Plug that into the second derivative here. Cosine of negative 2 pi over 3. Negative 2 pi over 3 is same thing as basically the third quadrant, right? So anything in the third quadrant is going to be negative. So that's going to be showing concave down, second derivative. Between negative pi over 2 and pi over 2, we can press 0. Cosine of 0 is positive. So positive second derivative is concave up. Between pi over 2 and pi, I can choose 2 pi over 3. Cosine 2 pi over 3 is negative. Second quadrant, cosine is negative. And this should match the shape of our graph that we've already created here. Right? Concave down, concave up, concave down. And so you will have your calculator to confirm everything that you're creating with your sine lines. Okay, how many points of inflections do we see? 2, yeah. There's change in signs. So we'll find order pairs at negative pi over 2 and pi over 2. Back into the original function. We know negative pi over 2, we'll treat it like 3 pi over 2. Cosine of 3 pi over 2 is just going to be 0. So it's just going to be left with negative pi over 2. Y of 3 pi over 2. Back into the original function. Cosine of 3 pi over 2 is also going to be 0. So it just leaves me with 3 pi over 2. So we have the most important points that we need. We have our order pairs at relative
max, our relative min. Let's also go ahead and find the order pairs at the endpoints. And then we can just sketch our graph, making our calculator find all the decimal values, so we can just have easier time plotting these points. So cosine of negative pi, same thing as cosine of pi. So it's going to be -1. -1 times -2 is a +2. And then pi minus +2 as well. So it's pi +2. Okay, so we're going to take all these points and use our calculator to sketch our graph. Okay, so following the path of our sine line, we know we're expecting relative max at -5 pi over 6, and that relative max, if we can plug in the calculator here, it's going to be some negative value. We can also plug in the calculator to get that approximated y value there. Like -0.9. At negative pi, it's going to be slightly lower than that. Negative pi plus 2, so -1 point something. Ultimately, we're just trying to make our graph look like what we see here. Okay. Relative minimum at -pi over 6. It's going to be -pi over 6 minus √3. So if I do a decimal version of that, just so I can have an easier time knowing where to put the graph. -2.2. And finally, we're going to end up at pi. That's around 3 plus 2. That's around like 5. So I'm just a rough sketch. We just want the graph to match the movement of these arrows. So rises to a relative max, falls to a relative min, and then continues rising. But along the way, we also know there's a point of inflection at -pi over 2. So -pi over 2 is somewhere here. And pi over 2 is somewhere here. So then we're just going back and retracing the graph with the proper appropriate curvature that we want. We want the graph to be concave down initially, then switches over to concave up, and then back to concave down.
Instead of
Oh, yeah, you're right. I should have done pi over 2. You mean right here? Yeah. Let me change that. I think you're right. Yeah, thanks. I did not change to the appropriate value there. Okay, should be pi over 2, not 3 pi over 2. That's what you got. Okay, thanks. Okay, let's spend a minute there just to fill in all of our interval statements as well as our because statements. We just pick all this off of our sign line, right? Interval increase, interval decrease, relative max, relative min. We can list out our order pairs and our because statements that go along with each of those intervals. Okay, for relative max, we want to list out the order pairs. We spent the time to find the y value. We also have reasonings though for relative max because f prime or y prime changes from positive to negative. Right? We can also now go to our second derivative sign line, list out our intervals of concave up, concave down, and points of inflections. Notice we're writing because statements for every one of these entries. Any questions? Okay, let's do another curve sketching problem. This is page 8. Whatever we don't finish will be your homework. So we'll just get as far as we can go. So page 8. We can make our calculator graph it first, just so we can get an idea of what we want our graph to look like. Again, interval is from -pi to pi. Okay, go through our process just like before. Find y prime, sine line, critical points. Derivative, sine becomes cosine, cosine becomes a negative sign. Okay, trying to find where is sine equal to cosine. It's going to be in that pi/4 family, first and third quadrant, right? But 5/4 doesn't quite land inside the interval from -pi to pi. So we can subtract 2 pi from 5/4 and get something that fits better. So -3/4 is a variation of 5/4 that fits. Okay, let's create our sine lines. Okay, we should be testing each of these intervals, but if we know the shape of our graph, just fill in. I do want you to find the relative min and relative max by hand, and not just the approximation using your calculator. So we're going to actually plug -3 pi/4 and pi/4 into the original function to get these order pairs in exact value form. Let's try that. Again, we can treat -3 pi/4 like we would treat 5 pi/4. So that third quadrant pi/4 family, √2/2, but negatives for both. Four. Okay, we've gathered everything that we needed from y prime. We have intervals of decrease, intervals of increase. We have order pairs of relative max. We have order pairs of relative min. Okay, moving on to y double prime. So derivative, cosine becomes negative sine, sine becomes positive cosine. Set second derivative equal to 0. Now we want where sine is equal to the opposite of negative sine. Still in that pi/4 family, but where sine and cosine don't have the same sign. So second and fourth quadrant, right? So pi/4 variations in the second and fourth quadrant. Through pi/4 fits nicely in that interval that we want, but 7 pi over 4 doesn't quite fit. We can find one that fits though by subtracting 2 pi. So we're going to use 3 pi over 4 and negative pi over 4. Those are our candidates for points of inflection. Second derivative sine line. Test negative pi over 2. Barrel test 0. Barrel test. We can also just look at our graph and kind of tell. Right. Starts off concave up. Switches to concave down. And back to concave up. Let's find our order pairs at negative pi over 4 and 3 pi over 4. Negative pi over 4, same thing as 7 pi over 4. Positive x, negative y. Ends up being 0, right? Find your endpoints as well. And then you can plot your graph. We have all the information that we need. And then fill in all of your statements of increase, decrease, relative max, relative min, including all your because statements. And you can check your progress with page 10. See how much you can get done in the next few minutes. Okay, your homework is just to finish page 8. And tomorrow, beginning of class, I'll just check page 2 and page 8. We pretty much have done everything in class, so just have to finish up a few things, and you can check your progress on page 10. Tomorrow, we'll do extreme value theorem and mean value theorem. Just make progress with our pathway. All right, can you get your phones?